I really want to also say a huge thank you to the Mini Analytics team. This event continues to be better and better every year. It's a really amazing event. We've been here for the 4 years that the Mini Analytics has been running this Data Tech Day. And every year there's always interesting content, always great people. So thank you very much to them, and thank you all for joining us today. I appreciate it. So I'm Michael Downs. I'm the Chief Technologist for Evolving Solutions. We're going to talk a little bit about data, which you're probably been talking about all day, and integrating external data with some of the data that's already in your environment. My background is with data is generally in platforms. So the first big data project I did was in around 2000 or so, where I worked for a company that acquired a small little group that was doing quantitative analysis in Cambridge. And we helped them move their SIGWIN, if anybody's familiar with that Unix emulator, from Windows onto actual computers where you could actually run the models in a day instead of a week, and they could actually get work done and actually choose to do trades. So my background has always been in that sort of the performance side and the platform side. Evolving Solutions is a local service provider, technology service provider. We are really focused on making sure that when you have gathered together all this data, pulled it all together, started to do your analytics, the only reason you do any of this is to get business value out of it. And if it doesn't run when it's up, you're getting zero value. Your business hasn't gotten what they wanted. So over the years, we've really built our business on this. It started like a lot of other companies, making sure that things like EMRs and SAP and other things like that that ran core business systems were up. As you're all really well aware, over the last 10 years, data has changed really radically. And we really are in a new environment because of the access of data, but also because of the ability of platforms to be able to do things with that data. I'm sure everyone's familiar with, many of you already use cloud platforms to do analytics, either do your testing or your development. Whether you're running it in production or not, the goal has always been to get the business value of what you're doing. And I love this quote from MIT Sloan Institute, because this is so true. This is what we see over and over and over again with our clients. You do amazing business transformation, you do amazing development, you run amazing innovation. And what happens when it gets to production? It didn't deliver exactly what the business wanted. It doesn't run the way you expected it to. It doesn't deliver what you thought you were going to get out of it. And so this is a place that Evolving Solutions really works with clients. This is a quick sort of snapshot of how we talk about working through things with our clients. And I wanted to just call out a couple things here today that I think relate to this. One of the big changes in data is that it's coming from external sources as well as internal sources. And being able to combine the two things together and having a platform where you can effectively do that is a critical piece of success for initiatives. And in just a minute, I'm going to have some folks from the weather company talking a little bit more detail about their experience with pulling that data in. But a couple of things that we've seen our clients struggle with are these couple of boxes that I've pulled out. Regardless of what you build, our new architecture is all about microservices. It's all about these little nuggets of ways that you're building your applications. In that environment, understanding what's broken is painful. And if you haven't built some sort of end-to-end monitoring capability so that you can start to understand where the value is, or more importantly, where things are stopping, or things are slowing down, whether or not you're getting what you need for your employees or for your end users, you're missing a huge piece of value there. And so we work with our customers to help stand up this kind of end-to-end monitoring so that they can get that value out of their application. The other thing we've seen really grow is data management. So public cloud provides all kinds of great capabilities. In fact, you're probably at least partly choosing the public cloud you're in based off of what you want to do in that cloud. It's not just the virtual machines, it's not just the storage or the cost of it, it's the capabilities that those public cloud providers are delivering. But in order to take advantage of any of that, your data's got to be in the right place. And when it gets there, protecting it, backing it up, securing it looks a lot different than it did for the last 10 or 20 years. And so that's another place that we find ourselves helping our clients. And again, take it a step further, I'm integrating external data sources to find some interesting insights, to just add some new value to my business, and that becomes even more complex. So we've worked with companies on a number of different kinds of external data. They're all interesting of a sort. The thing I think is really fascinating about weather data, one, it's in everything. And two, it shows up in ways that you wouldn't necessarily expect in terms of the value that it adds to a business. So I've asked James Peterson, who's over here with the weather company, to share some details of their platform and some of the things that they've seen clients struggle with and some successes they've had in the industry. So, grab that from me. You bet.
Hey everyone, I'm James Peterson. I'm a meteorologist. JP is what everyone calls me. How's everyone doing today? Good. I want to talk to you about weather data today. Thank you for being in here when it's really nice outside. I really appreciate that. It's a beautiful Minnesota spring day outside. Let's start a little bit with severe weather. It's pertinent to today. We've had just an active severe weather season across much of the Midwest, the South. We've had 14 straight days of tornadic activity, which seems like a lot. It broke a record from earlier in the 80s, so it's not unprecedented, but we've seen over 200 tornadoes touch down in the last just 13 days. Really quite extraordinary. We've all probably been affected by severe weather in one way, or one respect or another. This is a particular story I want to start to share with. This is Sharonda. She lost pretty much everything she had from a tornado, but she was safe. And her one-year-old baby was safe because she got a weather alert. She got a weather alert from a TV station that happens to buy weather data from the weather company, which is now IBM. IBM purchased us about 3 years ago, and we've done our full transfer of business in, so we now are IBM. The Weather Channel is a separate entity, but weather.com, the Weather Channel app, pretty much most of the weather apps you use on your phone, that's still our data. So she got an alert that kept her alive, kept her baby alive. It reminded me of a story. I grew up about 60 miles west of here in Hutchinson. Early 80s, there was a tornado that rolled through Hutchinson. I was just a little kid. After the storm came through, the sirens went off, we went down in the basement. It was really kind of the first time I remember understanding that weather is dangerous. Being a little kid, my dad took me down to his office to go see if there's any damage. We drove by parts of town, a grain elevator that got destroyed, a couple buildings that got destroyed. And you realize that, we're kind of just at its mercy, but we need to be informed about it. The better we're informed about it, the better chance we have to survive, but also we need data for that. And that's where the weather company comes in. Severe weather is not going to change. Disasters are not going to change. They've only been ramping up over the last 15 to 20 years. And the statistics are getting even worse as we look going forward. This was 2017. We all know how active 2018 was. 2019 is starting off obviously very active, severe weather-wise. But 90% of the global disasters in 2017 were caused by weather. 330 catastrophic weather events took place globally. Over 1,100 people died in just one mudslide in Sierra Leone caused by excessive rainfall. 31 of the 330 catastrophic weather events were billion-plus dollar weather events. That's a lot of money. And 24 billion of that was cost just to insurers, which is the second costliest year on record. 2018 is now the first costliest year on record. We're not trending in the right direction. So the weather company developed a proprietary platform to collect weather data from billions of sources around the globe. 2.2 billion locations currently are mapped every 15 minutes. So we are mapping the atmosphere from the surface to the top, basically wrap the globe in a grid of a 500-meter grid points, and that's what we're mapping every 15 minutes. That's a lot of data. We ingest over 400 terabytes of data every day. So to do that, we collect the data sources from IoT sensors, we collect the data from public sources, but we also collect the data from private sources as well. So we have 175 forecast models that are either public or private that we bring in. It's all about the data and the accuracy. We bring it in with Watson, we bring in pressure sensors from smartphones. The advent of the smartphone has been really a game changer in weather data collection. Anybody who has a Samsung 8 or newer, an iOS device that has a weather app, if you go to that weather app and pull down weather data, that geolocation uploads a pressure sense to us, to our platform. So we get hundreds of millions of pressure readings from smartphones all over the globe every single day. Watson IoT plays a big part of this. IBM brought the data in. We had machine learning algorithms. Now we combine that with Watson AI. There are 250,000 personal weather stations that Weather Underground had started with a weather network, kind of weather novices wanting to be part of crowdsourcing weather. We bring that in. That gives us that granular neighborhood look to fill in gaps throughout the country and throughout areas in rural parts of the world. That's another data point we bring in. Over 90% of all airlines use our weather data. Those planes that are flying, any given time, there's 50,000 planes in the air. They're sending in upper atmospheric data that we're bringing in as another data point. Add to that smaller data sets like radar and satellite imagery, ocean buoys, what's called SynOps stations, METAR stations, which are weather stations at airports. You bring all that in, and you put that with Watson AI, and it brings us to an enormous amount of data that is crunched very quickly and can be disseminated out in many different forms. So that's where the data science comes in. We have data scientists on staff that help with the Watson AI, that also help with other services and forecasting within the weather company, which they're all based out of Andover, Massachusetts. So we want to be the go-to trusted source for businesses for weather. And we're well on our way to doing that. And this kind of shows you a little indication why. We have 700 plus broadcast affiliates, so television and radio stations, 3.5 thousand businesses across 70 countries use our weather data for business decisions on a daily basis. And we've got the big players like Facebook, Yahoo, Google, and Apple that all trust us with their business decisions from our weather data. So weather impacts everybody. It impacts everything. It impacts your mood. It kind of provides a visceral response. You wake up this morning, if it would have been cloudy and rainy, I'm pretty sure there would have been some changed moods in the room of what the day is like, but you woke up, it's a nice spring day, sunshine was out, so it changes your mood. Might change, maybe I'm not going to get a hot coffee, I'm going to get a nice coffee. If it's cloudy and rainy, maybe I'm going to get a hot coffee instead. So right there, it's influenced a buying decision. So not only does it influence consumer behavior, but also then now influences how businesses react to that weather. And we want to make it so businesses are not reacting to the weather anymore, they're being proactive to the weather, and they're making decisions ahead of time knowing what the weather is going to do. The Institute for Business Value for IBM did a study in 2018, and they talked to a bunch of executives from different industries, different companies around the globe. And they asked them, does weather impact your business? 100% believe that weather impacted at least one cost and one revenue metric within their organization. 100%. 93% believe an improved weather insights could impact their annual revenue growth. So right there, they know it affects their business. They know it affects their bottom line. But look at the right. They don't really know how to utilize that information to make those decisions that affect their business. 69% were uncertain how weather data creates value. 60% have difficulty integrating weather data into their business processes on a daily basis. And 57% were uncertain how the weather impacts their decision making. So that's kind of the hurdle that we're getting over, is through information. Letting businesses know, helping businesses understand, it affects you, let's show you how it affects you. So again, it affects consumers, weather does. It also totally affects every single industry that you can think of. Some are no-brainers, right? Aviation, media and entertainment, but then there's a few other ones that might be kind of new. Obviously, agriculture, very affected by the weather. How about insurance and financial services? Or supply chain logistics, utilities, retail, advertising. All of these are affected by weather in one shape or form, but they might not know exactly how, and that's where we come in. To understand that, they have to know where the data comes from. Where do these forecasts come from? They obviously don't just create themselves. They have to be filled in with the data points. So in addition to what I talked about with upper air analysis, radar satellite, modeling data, personal weather stations, we also have a few other kind of newer data sets that are coming out that are taking us to another level of granularity when it comes to spatial and temporal granularity. One is numerical weather forecasting systems, getting much more granular. So this is for precipitation. Think of radar imagery outside of the US. US is pretty well covered with a radar network, but you get into areas of South America like Brazil, India, Asia, don't necessarily have that radar network. So now they need better radar resolution to really understand, because we're talking areas that have extremely large populations. So right now, this is an example of where a lot of countries have about a 15-kilometer resolution. But with that, you miss a lot of critical detail in some of these storms. I mean, we all have seen radar images, you know, the darker the red, the darker the purple, the heavier the rain. But is it really telling the whole story? So let's take that, let's cut that up, and let's make that even more granular. Let's go down to 3 kilometers versus 15 kilometers. And that's what's called GRAPH. This was in conjunction with NCAR, which is the National Centers for Atmospheric Research, working with IBM to take precipitation models from 15 kilometers in these areas that don't have a large radar network, like India, and bringing it down to 3 kilometers. Because right now, US, Japan, and Western Europe are really the only areas that can get that type of level of granularity on the precipitation. The forecasts, they're generated by a number of different systems. We have the data, we have the data science, and then of course we have Watson AI. So the normal data that often is out there is the radar, satellite, personal weather stations, and then the government sensors like I talked about, which is METAR. Now add into that even more high granularity precipitation models, and you're going to get an even better picture of what's happening on the ground in those countries. So with that, and the personal weather stations, we have now an unprecedented ability to gather IoT data all over the world. And IoT data is really the future of weather data collection. The personal weather station network, the more that grows, the more coverage we end up getting, the more data points we end up getting. In the agriculture sector, you're seeing a lot of large agriculture businesses, farms, putting IoT sensors out into the field. Combine that with drone technology, now you have IoT sensor data letting us know what's the soil temperature, what's the soil moisture content, what are we seeing for where we need to irrigate more, maybe add more herbicide because we're seeing areas that are being stricken by a certain bug or disease. All ways to increase yield and increase the health of crops. Another one is called MPAS. This is another model. Previous one was about precipitation. This one now is about just overall coverage around the globe. I talked to you a little bit about a 500-meter global grid. Now we're talking about a 100-meter grid that is, instead of 4 data points, now we've got 8. So now we're honeycomb-shaped, and we're getting even more data points within a small region. It's just going to help with our accuracy. And with that, you bring in a new supercomputer architecture, and we have all the power we need to compute the amount of data that's going to be required that comes in with that even more granular data set down to a 100-meter grid around the globe. When I talk to businesses a lot, I often ask them the question, what's their weather strategy? It's a very simple question, but a lot of times a business will be like, well, we don't really have one, or we've been talking about it, but we haven't really done anything. And it's a great way to spark the conversation with the business, because if they don't have a weather strategy, it's very easy to put one together. It might seem very hard, very complex, but it's actually very easy to put one together. So I want to show you a few examples of some businesses that we've worked with that have seen success by incorporating weather data into their businesses. Now, when I talk about weather data, we have REST-based APIs. So all of our data is raw data that can be integrated into models, into systems for businesses. And It's everything you can think of for weather data, from historical weather data back to 1979 on a 30-kilometer global grid, to current observations on that 500-meter global grid that's updated every 15 minutes, to 15-day forecasts that are updated every hour, to seasonal forecasts that go out multiple weeks, all the way up to 7 months. So we have pretty much the gamut, and we have even more specialty packages that deal with different industries, like travel, transportation, renewable energy, agriculture, so on and so forth. This particular business was a auto parts manufacturing business in Germany. If anyone's familiar with how a foundry works, this is where they pour the liquid metal into the molds to make the actual metal parts. If you know anything about a foundry, you can't climate control the foundry. When you have liquid metal, it's open air, so you're pretty much have to take what the weather gives you outside. Well, they were seeing a failure rate. When certain times they couldn't understand why, the molds would break up and the parts would fail. So they have to scrap them out and start over. So the data scientists from IBM came in, got a hold of the data for the weather, using historical weather data, and kind of looked and matched that up for correlations of when they saw failure rates. And a lot of times it's just the smallest little thing, and in this particular case it was dew point. When the dew point was above a certain threshold, the moisture particles, molecules in the air, bonded to the sand molds. And when you pour hot metal into a sand mold that has...
I'm having trouble with the connection.
Turn your Alexa off. So when you pour that hot metal into the sand mold, it rapidly expands those moisture molecules and causes small explosions, busting out the sand mold and causing the liquid metal to spread everywhere. So now, knowing that, all they have to do is schedule when they pour metal when the dew point is below a certain amount, and they are going to see a great increase in not losing parts from being lost through what they call the breakage of the sand mold. And there's a great quote from one of the clients that this is a breakthrough. So something very simple like that, which they did not know until they brought in the historical data. Another customer is Scott's Miracle-Gro. They use our weather data, currents and forecasting, to better improve their sales forecasting, to know, what's the weather going to be in these different regions, because different regions of the country experience different lawn issues, from molds to funguses to bugs, and so they need to better understand where to get their products out. So then it optimized their marketing spending and their supply chain. So now they could better market to the areas that we're going to see an increase in potential in maybe a specific fungus, and they could make sure that their products were there ahead of time and in ample supply so that consumers could buy these products. And they increased their annual sales by $30 million by simply understanding the weather. USAA Insurance, they're an insurance provider based out of San Antonio, Texas. They are one of the largest insurance providers in San Antonio, Texas. 2 years ago, San Antonio was hit by one of the worst hailstorms in the history of the U.S. Caused over $2 billion in damage just from one hailstorm. USAA, being a large provider there, obviously took a large financial hit. They are now using our alerting technology. This alerting technology sends alerts from us, pushes through into their USAA app, and then sends alert to their customers. So now they have improved member safety for their customers or members. They enhance their engagement to their customers. As we all know, insurance companies, there's a lot of competition. And they really would like to have customer touch points as much as possible. So that increased for them. And then of course, they sent it out. The alerts go out. There's a hailstorm headed your way. You have 30 minutes. Please put your vehicle inside or please take cover. 1 or 2%. Heed that. For a company this size, that's millions of dollars in savings from just one storm. Knight Transportation, one of the largest transportation and logistics companies in the country. This was kind of a bedrock, first of its kind solution where our weather data is being brought into their telematics, into their trucks, to alert their drivers of upcoming road conditions, upcoming weather hazards. So it boosts the safety of their drivers and the safety of their trucks. We know that a lot of you are probably from Minnesota or live in the Twin Cities area. The snowstorm that we had, it was a very rough winter here in the Midwest. I live in Des Moines, Iowa now. We had that late one that came in, shut down Interstate 90, shut down Interstate 35 in northern Iowa and southern Minnesota. There were a lot of trucks stranded on those freeways. So now you have truck drivers sitting there at a rest stop. Their load isn't moving. They're stranded. The snowplows couldn't get through. They sat there for a couple days. Now Knight Trucking has that lead time to know 2 weeks out, do we need to reroute these trucks or do we need to change the delivery? Because you have trucker safety, the actual safety of the drivers. You've got damage to the trucks, obviously very expensive if they go in the ditch and are damaged. So you reduce the risk there, and you aid the retention of not only the drivers, but you aid the retention of your customers. Because now you're getting the products to them in a timely fashion. Energy Envy Power out of Canada. We use an outage prediction solution that predicts where most likely you're going to see power outages ahead of a storm. And this is important. Think of an energy company. If they can better route their service guys and gals out to where we predict the highest probability of seeing down power lines is, they're not wasting time. So they're either not wasting man hours, and B, they're getting their the power back up quicker. So now they've got happy customers. And I love the quote from the CTO. We were recently able to reconnect 90% of our storm-hit customers within just 24 hours, which is a very positive result. Small thing, but in that line, getting people back up with power within 24 hours, that's a very critical thing. That is it for me. We'll go back to Michael, and we'll have some questions here at the end.
Thank you. So we work with a utility here locally, and they do analytics, of course, for trading energy on the exchanges and trying to understand where they're generating and when to sell, when to buy, and so on. And we were talking about cloud, and we were talking about moving some workloads into the cloud environment, and they said, well, we're not going to do power in the cloud, but there already exists. It's called Lightning. So one of the companies that we work with, so I just wanted to give a few examples of how platform affects data integration. This is a company that bought weather data through Evolving Solutions from the weather company that is a large metropolitan transportation system. They're using a lot of existing on-premise technology and combining that external data from the weather company into their current routing, scheduling, the rest of their platform, because they've been doing it for years. They have to keep that legacy platform and integrate the data that they're getting from the weather company. So that's one way of the platform coming together. Another really great example is a commercial landscape company that is, again, scheduling their drivers, but they have a more sort of, what I would call late 90s, early 2000s sort of data architecture. We're using open databases and so on. But again, same approach. They're taking an external data source, pulling it into their environment, and being able to make decisions about scheduling their crews and other kinds of things like that. And the platform, again, is critical for their success. And then just a third example, this is a agricultural supply company. They are actually a born-on-the-web company. They're completely a startup. So everything they're doing is in the cloud. It is cloud-based. They're actually providing agriculture services to vineyards and to coffee growers and things like that to help them optimize their yield. So they're providing an app to do that. Again, weather company data is a critical piece of what they do. They're generating their own data based off of the inputs from their various clients in their client base. So 3 different clients using data 3 different ways. Again, using your platform, making sure that platform is available, it happens in a lot of different ways inside of our clients. So I'm going to wrap up a little bit. If you've got some questions, I know JP and I can answer a few questions for you, but I wanted to say thank you very much. It really, weather is a piece of what we do every day. The way you use it, the way you integrate it with what you already do business to get value out of it is one of the most interesting things that's coming forward right now. So I'd love to talk to you more about it. We've got a little bit of time for questions, or if you want to come up and ask, we'd be happy to